Good evening, my YouTube viewers. It is Crystal here, and I'm here this evening to give you a code review for Kaggle's Playground Series, Season 3, Episode 8. I just happened to look on Kaggle today and noticed that they had another competition question, which I was quite surprised about it because in February their competitions are fortnightly, but they did have another competition for Season 3, Episode 8, which I am obliged to do. So what we're going to do is we're going to do a code review on what I did. I had a public score of 593. That was your RMSE, that's your roots mean squared error. So the problem statement for this competition question is the data set for this competition, both train and test, was generated from a deep learning model trained on the Gemstone price prediction dataset. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original dataset as part of this competition, both to explore differences as well as see whether incorporating the original in training improves model performance. So I didn't do that. I didn't use the original data set. I just used the data set that came with it. So I created the program in a Jupyter notebook sponsored by Kaggle or hosted by Kaggle, and it's in the directory of the competition question. So after we create our Jupyter notebook, what we want to do is we want to import the libraries. So we're going to import NumPy as MP. NumPy is a numerical computation library. And then we want to import Pandas as PD. Pandas is a data processing library. We're going to import OS, which is for the operating system. We're going to import matplotlib.pyplot as PLT. That's for your data visualization. And we're going to import Seaborn as SNS, and that's also for your data visualization. And then we're going to use OS to load the files. And when we load the files up, we find out we have 3 files being train, test, and sample submission. So we're going to use Pandas to read the files, and when I read the files and converted them to data frames, I was left with 3 data frames being train, test, and submission. So here's your train. It has 11 columns, the last column being price, which is your target, and your ID, which is ID number, which you don't really need because every row is indexed in the index. And so you have caret, cut, color, clarity, depth, table, and then you have XYZ. So we check to see if there are any null characters in the train data set, and there's no null characters, and so that's good. That means that I don't have to impute any null characters. We check to see, we check test, and tests is of the same format as train, except for the fact it doesn't have a price because that's what we're going to be predicting on. So we check test for any null values, and we don't have any null values with test, so that's good. And then we get submission. So submission, you have ID, and then you have price. So that's what they want us to do. They want us to predict on the price of the test set. So we analyze the target using Seaborn. And so we do a disk plot with KDE, that's kernel density estimator equals true. And so you can see this is what the plot looks like. So it's very heavily skewed to, I'm going to say it's skewed to the left. I mean, I'm not that good on skewing, but I'm going to say it's skewed to the left. We check our value counts. We have quite a few values that appear only once, and we can't do anything with that when it appears only once because the model can't predict on it if it appears only once. So what I do is I insert code to remove any row that appears only once. So I filter out the rows, so anything that appears more than once is going to be in train, and anything that appears only once is just dropped. And then we check the disk plot again, and you can see that the plot that it makes is similar to the previous plot, but it doesn't have as many ones in it, or it shouldn't have any ones in it, because those have all been removed. And you can see that we have 193,558 rows after we removed the ones, and we had 193,573 rows before we removed the ones. So we did remove a few ones. So now what we're going to do is we're going to analyze the target. So we're going to create a box plot of the cut and the price. So you can see the cut and the price as well. So a premium cut costs more than other cuts. And it's strange because an ideal cut is actually less than a fair cut. So that's unusual. So you can see the cuts. Now we're going to do another blocks plot with the color. So we're going to compare the color to the price. And so I don't know what the colors are because they just encoded them. But you can see it looks like color number I and color number J are the highest prices, except for the outliers, because there's quite a few outliers. And then what we're going to do is I did a scatter plot, and so we do a scatter plot on the carat and the price. So you can see that the more carats it has, the higher the price. So that's interesting. So now what we do is we combine our train and our test set. We take the target equals train price, combi equals train drop price, axis equals 1 append test, and then you have combi. So we drop ID from combi because you don't need it. And the reason why you don't need it is because every row is indexed. So we check info, so we see that we've got a bunch of floats, but we've also got quite 3 object columns. And then we check the shape, we've got 9 columns. And then we check for unique values, and you can see all of the unique values in the different columns or features of the data set. So now what we want to do is we want to ordinal encode the 3 object columns. And the thing about ordinal encoding is whenever you do it, you have to combi call dot values dot reshape -1, 1. You have to reshape the column before it'll work. So that's the code that you need. So it's important to know that you have to reshape the column before it will work. And now you can see here that all of the rows or features are numeric, which is what the model wants to see. Now I've created a heat map. And what's interesting with the heat map is X, Y, and Z are very highly correlated. So that's something that's going to have to be dealt with. We check the correlation. You can see the correlation between all of the features. And again, you can see X, Y, and Z are very highly correlated. So what we do here is we insert code to remove any columns that have a correlation of greater than 95%. and that's the code that we use. And so after we've inserted that code to remove any columns that are greater than 95% correlation, you can see that we only have 6 columns now because the 3 columns X, Y, and Z have been removed. Now what we're going to do is we're going to normalize COMB, and we're going to take every cell and convert it to a value between 0 and 1. And the reason why we do that is because it's easier for the data to be trained and fitted into the model when it's close together, and when it's in the same dimension, it's easier to make predictions on it. So now what we have to do is we have to take the we define our dependent and our independent variables. So Y is your target, X is COMB, the 0 row to the length of train, and X test is COMB, the length of train to the end. And now what we do is we insert code to split the data set up into training and validating sets. So we have to take target and we have to add that to X to make it one data set to have X and Y variables in it. And then so your train is a sample of X, a 90% sample of X, and your val is the train is X, but it drops the train index. And then so X train is all of the columns except for the last one in your train, and Y train is the last column in your train. X val is all of the columns except for the last one in val, and Y val is the last column in val. And so now what we do is we check our shape because we want to make sure the shape's okay, and the shape is okay. We select our model, and I decided to go for XGBoost because XGBoost performs very well. So model equals xgb.xgbregressor.fit xtrain ytrain, and then we print the score. We have a 98% accuracy. We predict on the validation set. So ypred equals model.predict xval, and then we print the score, which is about 98% as well. So we check our RMSE, that's root mean squared error, and we have a 575.9 error rate. And then what we do is we compare the actual values to the predicted values, so you can see the actual values and the predicted values. So now what I do is I plot the actual values against the predicted values onto a graph, and it doesn't look too bad. We've got a few outliers, but other than that, it doesn't look too bad. All of the values seem to be hovering around the prediction. And now what we do is we predict on the test set, and we take it and we convert the predictions into an integer, and then when we then any prediction that is less than 0 is going to be 0, and then we have a prediction, and we take the prediction and we put it into the submission. So submission price equals prediction, submission to CSV, and then we're going to convert it to a CSV file called submission. Submission equals PD read CSV, and this is our submission. This is our submission, and this is what we have submitted to Kaggle. And then whenever I submitted it to Kaggle, I got a 593.86 score. And so if you want to look at that playground series, so this is it. This is the playground series episode 8. If you want to look at the leaderboard, so there I am on the leaderboard, 593.8685. And there I am somewhere down there, 96. So I'm number 96 on the leaderboard. Now, if I wanted to, I could try harder to improve my score on the leaderboard, but I'm happy with that. I'm happy to get on the leaderboard, and I have lots of responsibility and lots of work to do, and I don't really have a lot of time to be trying to improve my score on the leaderboard, so I'm just going to leave it like that. So I hope you like my code review, and this was my first attempt, so you can see here, see where I am on the leaderboard, and it tells you it was my first attempt. So that's going to be my only attempt for the time being, because I have lots to do. So thank you so much for watching my video. Thank you to my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future.